Revise what we have discussed, right? We started knowing about content, right? Which all topics we are going to discuss. We understand that we will be discussing Spring Framework, Spring Boot, and microservices. And we understand that Spring Core module is the fundamentals module or foundation module that we need to learn first. So this is the first module that we have to complete. And to understand more about Spring Core module, first we started with the MEC architecture, model view controller architecture, which is common for any technology, for any application. It's a common architecture that everybody follows. Yeah, am I audible? Yeah, yeah. It's a separate record, not from the go to. Okay. So this is a common design pattern. Okay, not only in the Java or for any other technology which they are implementing any kind of web application or enterprise applications will follow same architecture. So you must aware of this architecture, MVC architecture. Everybody must aware of this architecture. Okay. So because this is a common architecture everywhere, what this architecture says, without this architecture also you can make some functioning code, working code you can design without following this architecture also. You can create front end, back end, everything together. Okay. You can create everything together into a single file. Right here you are seeing one view layer which we are calling front end, and a back end layer. There we have controllers, business, DO classes. You see there are different layers. Instead of having this many layers, you can keep everything together into one file. Everything view code, right? You can put the view logic, back end logic, everything together into a single file. Okay, in one file. If anybody knows servlets, right? Servlets are JSPs. Inside servlet, we can put all the backend code, all the front end code, everything. Even in JSP also, we can code. Okay, it will allow you everything, front end, back end, everything we can put together. But that's not a good practice. That's not a good practice. If you put everything together, maintenance of that application will become so difficult. Morning, please calling. Just a minute. Hello. Yes. సార్ నేను క్లాస్లో అయిపోయాక చేస్తాను. Yeah, instead of coding everything together, we should divide them logically. Otherwise, maintenance of code will become very difficult. If you are a fresher, you may not understand this statement, but if you are working and if you deploy it into any existing project, you know the pain if the code is not readable. Somebody developed and they left the company, you joined there, and one task assigned to you on a existing code, and you are not able to understand it. And the client asked you to do some queries changes, or client asked you to do some business changes, and you went to that code and you see the code is very clumsy, front end code, back end code, everything implemented, and the code will become very sensitive. If you touch one, it may break the entire code. You don't know whether that code after changes will function it or not, because unit testing is also not so easy. As everything is together, you need to again run this application, end-to-end testing you need to perform. So if you implement small pieces, that only particular piece I can able to test. If I do business changes, I can just run unit test on this business changes and I can see the result, whether my code changes are giving proper result or not. But and when you put together everything into a single class, if somebody try to understand, it is very difficult to them. So maintenance will become very difficult if you don't follow this architecture. That's why everybody will follow this architectural design pattern. It is a standard pattern, okay? It is a standard pattern everywhere. So you just need to follow it, okay? So as per MVC architecture, we will have separate front end. Nowadays, complete front end teams are working on this part as a Spring developer or a Java developer. Our part is this right hand side part, back end part. Separate Angular teams or React JS teams and mobile app teams. They are completely independently working on front end part, and we are working on back end part. And how they will communicate with this backend, we are sharing APIs with them. Nowadays in web services we are sharing APIs we are sharing with them, so they are just integrating with APIs. We are giving API is nothing but a URL. Along with that URL we will provide input and output object. We will say this is the input, this is the output objects you need to send. We are REST calls. API is all about REST and input JSON, output JSONs. So mostly using APIs, they are integrating with backends. So no confusion. And this APIs we are sharing with some Swagger kind of documents that is automatically generated in Spring. So we are sharing that URLs with them so that they can understand what you implemented backend. They don't see your code, but they can see what is your input link, REST link, and what input they should send. If they send input, what kind of output they can expect. So that is sufficient for UI team. UI team easily they can understand what data they need to send. Let's say you implemented a registration form here with name, email, address. When you share your API with them, they will see that okay, controller implemented with name, email, address. In UI also I need to create name, email, address. So he will create UI with name, email, address, and he will send that data to your API, name, email, address to your API. So obviously your controller will accept the data and it will proceed from there. This is the current pattern that everybody following. This is the current pattern that everybody following. Okay. So front end team completely independently they are working and back end team also working. And between right like leads or full stack developer, he is putting stuff here and here, both the sides. Mostly leads should have that commanding. She should able to monitor UI and backend both. Otherwise, sometimes there will be some challenges. Okay, front end team may not understand APIs properly, or backend team may not understand what front end team is sending. Some collaboration or communication must be required. Okay, there should be some full stack developers also who knows both, but independently they can work. If you have team 4 members of UI UX and 5 members, 10 members of backend team, they can independently work. There should be lead who can able to understand both, just to manage better. Otherwise, there will be so many miscommunications might happen. Though they have API document everything. Okay, yeah. So our majority or major part is on backend. So front-end teams autonomously or independently they can work here, and back-end teams work on back-end instead of you know creating everything together. Independent teams can work. independently so that we can deliver things very fast. Instead, you hire a full stack developer, he writing everything together and making uncomfortable for the future changes. I mean, without following MVC architecture. If they follow MVC architecture and create separate front end and back ends, easy maintainable. So back end side again, the Java code we will break it down into three layers. One is controller and one is business and one is DAO. Controller will deal with front end. Whatever data coming from front end, it will accept and reads the data controller. So this is the first point of contact for the front end. In terms of classes, which class will read first data which is coming from front end means controller. Once the data is reading, controller will send it to business for doing any business calculation stuff. Once the business logic is done, business class will send it to DO class. Can't we write them together means we can write, but that is not a right way of coding. We need to separate them. Controllers will do only read and write operations. From UI, it will read data, and while sending response to UI also, controller will send the response. The response output JSON, controller only will send. The input JSON also, controller only will read. So the controller is the backend class which connects with the front end. Then controller will send data to business, business send data to DAO, and again will DAOs will play a crucial role here. They will connect with databases. Databases are not in Java. Again, they need a separate programming, SQL. So we will be writing all the SQL's part here. SQL queries here to save the data or to retrieve the data or to update or to delete whatever it is. So DAO will hold all that SQL stuff for doing CRUD operations. So when you do logical separation, the benefit is in future if somebody else or if you want to go and do the changes, it's easy to you to understand your code. It is not too easy to understand your code also. I written some code 5 months, 6 months back, and I was continuously working on other tasks. When you revisit your code, you will surprise that and you will think, is it the code that I implemented? Of course. Always our focus on current tasks. So obviously we will forget what we have implemented. But if you have followed this architecture, it is easy to you to understand. Okay, some SQL code I implemented that should be part of DAO. You can go to the DAO and you may do some changes as per the current requirement and you can test it easy. And if there are any business changes, you may go to business class and you do the changes there. If there are any new fields requirements came that new field need to be added here, phone number, so that you need to address in controller, maybe everywhere. So you will go here and you will add that extra new field if at all that change is required. That's how we can able to add the future changes also here. Okay, why I'm telling all this story is once after Spring, while implementing your applications, you will be following the similar architecture. Even during coding, I'll follow the same architecture. During our examples also, we'll follow the same architecture pattern. There are so many advantages. Slowly, one by one, we will learn them. Okay. And everywhere, right? Earlier, we have different frameworks to provide support for controller business DAOs. But for everything, Spring became an alternate. For everything, Spring became an alternate here. For controllers, they given few modules. To handle business logic, they given few modules. And for DAO also, they given few modules. What are they? If you see here, core module is everywhere, like your core Java. If you ask using core Java, what you do means you can do anything. All the algorithms, logics, everything we write it in core Java. Similarly, Spring Core we use everywhere across controllers. Spring Core will be using everywhere. Controllers part, business part, DAOs part, everywhere we use Spring Core module. What about JDBC? You know that JDBC will be used DAO part, ORM also for doing CRUD operations. For DAO layer only ORM will use. AOP we will use between controller and business. So you may say business layer. We will use AOP particularly in business layer. Transactions also we will apply from the business layer. Transactions basically to control the database actions, but that we will operate from business layer only. Spring security, authentication and authorization will apply from controller layer only. And MVC is purely for controller. So you can understand this modules meant for which layer. So for each layer they given modules to implement DAO classes, to implement business classes, to implement controllers. And what about boot and microservices? Same story with advanced way of coding. All these modules are available in boot also with the advanced programming. Okay, they made it simple. Here, whatever we write code, that code they avoided and they made it very simple. But the same support we have in Spring Boot as well. Microservices is a concept to make applications smaller. That's it. Otherwise, it's not a different thing from Spring Boot. Okay. So across MVC implementation, they have given modules. Controllers, business, DAO, there are many modules from Spring. Once after knowing all these modules, you can able to implement end-to-end Spring application. Of course, after these sessions, you will get that command. I'll be showing you all the including front end also, right? Few front end screens with back end also I'll be showing you so that you will get end-to-end knowledge. And Spring Core is the foundation module that we need to learn first, as I mentioned before. Okay. What is the first thing that we are learning from Spring Core module? Pozo class. Across your backend, what you will implement whenever you get front end data, you need to from front end whenever you get data to read that data, you need to implement a controller and to handle business logic business to handle DO operation DO. But do you need to write this controllers business DOs with the different strategies or with the different way of coding, like in servlets we extend HTTP servlet, or in EJBs we extend EJB session beans, EJB entity beans. If you know them, it's okay. If you don't know, don't worry. There we used to, create our classes by extending from other APIs, and we used to put a lot of dependencies. Spring is not recommending that. Spring is saying just go ahead and write your class as a POSO class, simple plain Java class, so that your future changes or enhancements are very easy. Spring is saying don't do any complicated logic or don't make your classes as complicated. Make your classes always simple. So that simple class itself is POSO class. Simple class means POSO class. So Spring saying make your classes simple, not too complicated. So we call that simple classes as POSO classes. Simple Java class. Simple Java class, you can say POSO class. Can you all give me an example of simple Java class? Can you write it in chat? The chart is available for you. Give me a simple Java class with methods or without methods, with variables or without variables. Write a simple Java class and share it here. Everyone, share me simple Java class, simple POSO class. If you're all following me, just give me. Okay, great. Window given. public class teacher. Others, I'm waiting for you guys. Sailesh, Vinod, Vasu, Mayank. Okay, Vinod given some class test with ID and name variables. Sailesh given class student. Hmm. I got three classes. What about others? Give me any class, okay? Sailesh given private class, Vinod given public class, Shavni also given public class. What about others? Mayank, are you not ready with keyboard? Yeah. Just give me between. I'm copying that classes, okay? So public class teacher, which is Ravani given a simple poser class. A simple poser class. I'm creating a Java project. So this is the class that Shravani shared, public class teacher, right? And Vinod given public class test. Yeah. Okay. Was also given one class. Sailesh given class student, private class student. We'll see why it is given here. Okay. Private is not allowed. It is said, or it is asking to make it as a final class instead of private. Okay. Shall I make it public? Yes. Vasu given including package name. So class. And this package is not available. And constructor we should override. Package not available. Let's create package. Yeah. And one more class, employee. And I don't see your name. I see two participants' names are waiting for name. Okay. You mentioned setters and getters. Okay, that we can generate. If you want setters and getters, go to source, generate getters and setters. You can generate. So these are all the classes that you have given. Yeah, if you know how to create simple Java class, there itself you learned almost 5 to 10% of coding. Okay. You know how to create package, you know how to create class. Spring is saying create as much as simple classes for your application while implementing your controller services DAOs. Don't make them complicated. These all are the simple classes which you have given. I don't see any complicated class or any inherited class. Employee, a simple poser class with a few variables and getters and setters. Student, a normal class, empty class. Teacher, a empty class, simple poser class. Test, a simple poser class with ID and name. And one more class, student, with simple string name and a constructor. That's it. These are not the poser classes. And if I ask you to create objects for this poser classes, how you will create? Now type for each of your class, right? How you will create object? How you will create object here? Okay, okay. Okay. For employee, you will be creating employee emp equal to new employee. Okay. So this is how we can create employee object. So it is asking to import, or class name might be wrong. It is there outside the package. So default classes not able to access. Let me put it here. All these classes I'll move to package. So this is how I can create employee object. And if you want to call any methods, this class should have methods. As of now, we have getters and setters only. So using setter method, I can assign one name, set employee name, and I can print that name just by calling get employee name. The purpose of this class is I want to store some name, email, code data, and I want to utilize that. I can able to achieve it. I am calling set employee name, storing Praveen and printing it. Instead of printing, you may send it to front end or database. Okay. So employee class object I can able to create. So using new keyword, I can create any of these class objects. Student object, teacher object, anything I can create here. So using this new keyword, I'm creating an object for them. So when actually your code, whichever code you have written will execute, when this new keyword starts execution, there your object will be created into your machine. Here actually at this line it will load into machine. Here it will load into machine, or it will create object into machine. So this is the key place where actually your object is loading into JVM. This is the key place. You have created all simple classes, and when you want to execute them, there you are using new keyword to create object, and from there actually the journey of that class will start. For whatever purpose you implemented, that purpose you will start execute. But in last session, if you remember, I said using new keyword is not recommended. So using new keyword is a way of static coding, static way of object creation, static way of object creation. In core Java itself, instead of new keyword, class dot for name approach also available. Using class dot for name also, we can create this class object. We need to give the class employee class or employee dot new instance, it can create this employee object and you can finally get it. This is dynamic way of coding or dynamic way of object creation. Dynamic way of object creation. So it is asking you to surround with the try catch, you can put it. So this is other way of creating object. Instead of static object, we can create by using class.forName dynamic approach also. So in this dynamic approach, it will allow you to pass any class name here. So here if you see this code is creating only employee object. Now let me delete this and let me delete this complete code. And in each class, right, which you have given, I'll put a constructor. In employee class, I'll put a constructor system.out.println employee object. Similar way, student, just I'll override default constructor, student object, teacher class, override default constructor, and test object. So now here in this main class, instead of creating object with a static approach, if I go with the dynamic approach, class dot for name, I'll pass argument, command line arguments, everybody knows, right? I'll pass my command line argument, zeroth argument. Whatever you pass via command line argument, for that class it will try to create object. Okay, it will create object. You may put throws declaration or you may put it under try catch. If you enter wrong class, it will give you exception. Okay, now see how to run this. Earlier I created only employee class object. I can't able to change that in future. But here now I can change it. I'm giving employee class name here and running this. Oh, argument is 0. Don't we have constructor? We have. Okay, it is under main package. We have given default package name. That's why it is creating default employee object. This default class is not having any constructor. Okay, give including package name or delete these classes. And configurations, package name main.employee. Employee object is created. And if I need other object, any other entry, I need not to edit my code from this what VM arguments. I can change my decision here. I don't want employee. I need teacher object. Yes, I can give teacher class name. So it is creating teacher object. So now onwards, dynamically I can able to change my decisions, change my code. Dynamically, I can change my code via VM argument, or maybe some files you can use to change your class names, like properties files. There are many ways to enter your dynamic inputs, command line arguments, properties files, or XML files, or text file, anything. So from this class.forName, what we understand is object need not to be created with a new keyword. With a new keyword, if I try to create, only I can create employee object here or student object here. If I want to change my decisions, I can't change them easy. I should edit this code and I should change it. So earlier I was able to change employee to teacher, teacher to student easily. Now if I run this employee object, I can't change it. If you want to change it, you need to edit this code. So instead of doing coding or instead of creating object in a static way, it's always recommended to use a dynamic way. Why? Why? Because Java supporting runtime polymorphism. So static way of object creation will not add any benefit to runtime polymorphism. Again, you may ask what is runtime polymorphism. Yeah, I'll explain you that. You came across in your core Java, but still. As per runtime polymorphism, you have a great benefit that you have not realized yet. You have a great benefit, but you did not realize it yet. Let me explain you that. We are not deviating, right? I am on to the context. I explained you POSO class. The next step I am saying, don't use new keyword. Instead of new keyword, we need to use class.forName. Now I am giving you advantage of it. Okay, the advantage you will realize it now. Just be focused here. Okay, runtime polymorphism you must learn in core Java, but in the real time you may not realize that context. Let me explain you that runtime polymorphism. In Java, you know that object class is a parent for all the classes. This is a parent class for all the classes. Whichever classes you have returned, default classes, they may not extend it from the object class till they are default childs for object class. True, right? So object class is parent class for all Java classes. If you extend it or not, it is the default parent. Okay. Then what is the benefit? Every object which you create, that you can store it into object class. As per Java, you can hold, we can hold child objects into parent references. You must learn this as well. What is that statement means? You given me a teacher class, a employee class, a student class, but you did not extended them from object class. Though you did not extended them also, always your classes are childs for object class. Teacher class is a child for object class. Employee also child for object class. Student also child for object class. Then we can hold child objects into parent references, which means you can put like this object emp equal to new employee. This statement is true. We can able to hold your object into parent reference, child object. Your object is child for all which class? Object class. Same thing you can do like this as well. Student and teacher. It is possible in Java. It is possible in Java. We can hold child objects. We can hold child objects into parent references. What is the benefit? I'm taking you up to there. Okay, I'm taking you up to there. The benefit I'll show you. The benefit I'm going to show you now. Now using this principle, I'm going to achieve one. I'm going to achieve one benefit here. I'm going to achieve one benefit here. See, I have a class. See, I have a class or interface. You know, right? What is interface? Interface will not have any code, just a declarations. Interface phone I have. Interface phone I have. Public void calling. I have a method called public void calling. No implementation. Thus, no implementation for it. No implementation for it. No implementation here. And I have one more class or interface sim public void connect call. So no implementation. These two are interfaces. These two are interfaces. Interface is nothing but declaration only. We don't have any implementations. Generally, when you try to implement a phone, what is the main feature that you implement? Calling feature. And when you provide SIM card, what feature you will try to provide? Basic feature connecting to calls. So those are the basic things. Okay. Now I'm going to show you the benefit of runtime polymorphism here. Okay. From this phone, by implementing this feature, iPhone provide implementation class iPhone implement keyword we will use, right? From interfaces we will use implement keyword to implement our class. Using implement keyword, I'm implementing phone class. Obviously, next thing what you need to do when you use implement keyword, when you use implement keyword for interface, you have to must implement this method public void calling. Means iPhone must implement calling public void calling. Public void calling system.out.println call into given number. And same way SIM card class geo implement keyword geo SIM card implementing SIM. So here you need to implement public void connect call system.out.println connected to given number. I implemented it. Okay, what is the benefit? What is the benefit out of it? Without providing interface also I can implement them. Of course we can implement. But now see the beauty of it. I implemented them using interface. Okay, I implemented iPhone from phone interface. SIM for Geo from SIM interface. Now here the user coming into the picture. The user class. Consider one of you I'll consider as a user. One of you I'll consider as a user Vasu. Now class dot for name approach, right? I said instead of static way of coding, we will use class dot for name approach. Public class was user main method I have. Now Vasu want to use a phone here. If Vasu hard coded with iPhone, phone equal to iPhone, new iPhone, in future if you want to change from iPhone to new keyword he is using. Okay. And SIM Geo he created and he connected iPhone with the Geo and he is using happily. But here Vasu code is hard coded code. Hard coded. Hard coded meaning using new keyword it is implemented. Using new keyword we are using new keyword we are using this phone and SIM. So if Vasu want to change the decision, he want to change from my phone to Android or some Microsoft phone or whatever it is, Nokia phone. He want to migrate. So when Vasu want to migrate, he need to edit and do changes here. Means he need to change all the agreements. He need to change all the code. So changing decision is not too easy to Vasu. Not too easy to change phone and SIM. Now I'll write one more class. Vinod. Class public class Vinod. For Vinod, I'm using a different approach. Instead of static way of coding, for Vinod, it is implemented in a different way. How it is implemented using class dot for name. Try catch is required. Okay. So for Vinod, I'm using dynamic arguments or command line arguments, you may say. There are many ways I'm using command line arguments to pass the inputs. So here I'm creating object this way. Phone p equal to class dot for name of argument 0 dot new instance. New instance. Okay. Maybe you need to typecast here. Okay. So into what type I am typecasting here? Interface type. What I am expecting as a 0 argument here? Any implementation object. iPhone is the implementation. I will pass iPhone here as a input. So command line argument what I will pass? iPhone only I will pass. In command line argument I will pass iPhone only. When you pass iPhone, it will create object for iPhone. And as per Java, you can hold iPhone object into its parent reference. Phone is a parent. Phone is a parent. In that phone, you can able to store your iPhone object. Good. Same way, SIM object also I'll put. Class dot for name. Let's copy paste. Geo. So now, if Vinod wanted to change from iPhone to Android or any other phone, does he need to do any changes in his code, Vinod? Or if you want to change from Geo SIM to Airtel, does Vinod want to need to? do any changes here? No. See, a small change or a small way of dynamic coding made this Vinod's class very much dynamic. Not only iPhone, in future one more phone implemented. That new phone also Vinod can able to adopt it. If he don't want Geo, he can go with other SIM also. Other SIM implementation also without doing single line changes in his code. See a simple benefit in real time, right? Whenever you want to use phone, iPhone, you might be using iPhone. If you want to switch from iPhone to Android phone or any other phone, easily you are able to migrate because every phone is providing calling support. So without hesitation, you are selling your old phone and you are buying new phone, and into that phone you are adding any SIM card because every phone is providing a SIM slot. There you can able to put Geo SIM or Airtel SIM, anything. A universal interface they are giving, so you can use it. So we have such a flexibility in phones itself, SIM cards itself. Can't we bring that benefit to our coding while implementing applications? Can't we such a flexibility in our classes when you implement controllers, service, DO classes? Can't we bring that flexibility here? Means yes, we should able to. When you will get that flexibility to your application, instead of hard coding it, instead of hard coding it, instead of hard coding it, and instead of putting directly into the same class references, iPhone object kept it into iPhone only, Geo object you kept it into Geo only. Instead of using this, Java is providing you great feature. You can put always your objects into parent references, so that in future if you don't want this child, you can remove this child and you can implement another child. Still your code will support. This parent class will support another child also. You need not to do any changes in your code. Without doing changes, much changes, or without any changes, your code will function as usual. When you change a SIM card, or when you change a tire to your cycle or scooter or car, will car says no, I don't drive because you added a new tire? No, it never says. Or will phone says you added a new SIM so that I will not function? No, it never says. Similarly, your MVC classes also should not give any issues while you are changing, right? If you consider this is controller is your phone, and business is your SIM card, so controller should never say don't change SIM, right? You should flexibly, you should able to change your code. If you imagine controller is like a phone, this phone should allow you to change this SIM easily. If you consider business like a phone, DAO like a SIM card, your phone should allow to change the SIM card. In case if you want to change phone itself also, you should able to change, vice versa. Just a minute. Okay. So instead of going with the static approach, if I go with the dynamic approach, that much flexibility I'll get. Easily I can change my decisions. Same thing you should able to apply to your MVC also. For that, do I need to really use the Spring framework? Other frameworks means nothing. In your core Java itself, you have this benefit. Just if you follow parent reference equal to child object with the class dot for name approach, you will be getting that benefit. But nobody tells us use this approach. They always code lazily with new keyword. Don't use new keyword. If you use new keyword, your class will become tightly coupled, like CDMF1. Okay. So Java is providing this runtime polymorphism support. You can hold easily child objects into parent references, and child objects creation also need not to do in a static way. You can create it a dynamic way. Altogether, by creating a dynamic way of object creation and by holding it into parent reference, you are you are achieving a great flexibility, isn't it? See, you will easily realize with this example. Same thing we should apply to our MVC classes. Same thing we should apply to our MVC classes. Why I'm telling all this story means Spring is using or Spring is saying follow this approach to make your application simple, flexible, easy maintainable. Okay. So runtime polymorphism. Okay, this is not my Spring concept. Okay, this is core Java concept only. So please try to understand. You must went through that sessions in your core Java or may not, need not to worry. I'm telling you again here, okay? So I'm creating here a interface, same example I take so that it is easy to you to understand. A phone interface I have, public void calling, no implementation. Interfaces will not have any implementation, okay? Just they are the signatures, which means while implementing, right, you need to implement the same signatures. Public void connect. So whoever wants to provide implementation or while providing implementation, you need to extend your class from there. iPhone implements phone interface. So must it will ask you to override calling method. Okay. System.out.println calling from iPhone. Okay. One more implementation I'll provide. In market we have a lot of phones. Like iPhone I have. What I'm using my phone is Redmi. Implements phone interface. So Redmi also will support calling from Redmi. Now Sims also. Lot of Sims we use. Even two Sims at a time we are using. Geo implement from sim interface. Similarly, I can implement something Airtel implement sim. Now let's see two users. One user is old way of approach he is using. One user is dynamic approach. If Vasu is using static way of approach, so he wanted to use iPhone only and static way of objects he is creating, calling. So always Vasu should go with this iPhone and Geo only. He can't change decisions dynamically. As because his code is hard coded, calling from iPhone and connecting calls with the Geo. He can't change decisions. But instead, Vinod used a dynamic approach. Vinod used a dynamic approach. He understands the benefit of runtime polymorphism. Instead of coding in a static way, Vinod did it in a different way. What he did, he used class dot for name, argument 0, need to pass 4, class dot for name, args 0, new instance. So here is expecting implementation, phone implementation class, anything. So he can finally typecast it into phone. Phone is an interface. Into phone interface, any implementation we can typecast because phone is a child. Any implementation it can able to capture here. Now using this interface, you can call calling method. Generally, calling method doesn't have any implementation here, but whatever class you will pass here, right? That class object will be executed here. So that if you pass iPhone calling it will execute. If you pass Android phone, Redmi phone, it will call to Redmi. So this logic is sufficient for any phone. Same way for SIM. Pass Jio SIM or Airtel SIM, you can connect to calls. Same logic will support you for both. So what he need to do via runtime arguments, Vasu, we know the class. Okay, we know the class. In runtime arguments, he need to pass as an argument 0, he need to pass any phone implementation, and as an argument 2, he need to pass any SIM implementation. Okay, so via runtime arguments, two arguments he need to pass. One is beans dot iPhone space. Between argument and argument, we will use space. iPhone space beans dot 0. Calling from iPhone, Geo connecting to calls. Now Vinod thought that okay, he bored with iPhone and Geo, he want to shift to Android for a few days. So what he can do, he can go here, he can change the decision. Instead of iPhone, he can shift to Redmi. Just if you want to change only phone, he can change the phone, Redmi. Calling, in Redmi, didn't we change the code? We changed it. Yeah, yeah, yeah. So this is changed. Okay, Redmi and Zio. Now see, Vinod is flexibly shifted from iPhone to Redmi. And if you want to change the SIM also, he can able to switch. He can play whichever phone he want, whichever SIM he want. He can easily play with it. Now he want to change it to Airtel. We can do Airtel here. See how much flexibility he got. What he did differently means a dynamic approach he used. Whereas Vasu used a static approach and he struck with only one phone and one SIM. Whereas Vinod used a dynamic approach. Now he's having flexibility to change phone anytime, to change the SIM anytime. That is the beauty of dynamic way of object creation with runtime polymorphism. As per runtime polymorphism, we holded our implementation into parent reference. So then we achieved runtime polymorphism. This is what runtime polymorphism, getting flexibility of changing things dynamically. Easy. Such a flexibility we need to give to our applications. Okay. Remember these statements. Okay. Such a flexibility we need to give to our application classes also. That's how when client want to change decisions, easily you should able to change it. Right? Of course, business always needs a lot of changes, lot of strategy changes. As a personal itself, we are daily, today we will eat one type of meal, tomorrow we will eat a different type of meal. We have dynamically our, digestion system allowing it. As an application, your application should have that flexibility. You should able to apply changes easily. Such a flexibility you should give to your application. We are technical people and engineers. We should design application in such a way. We should not build a concrete code which we cannot change. We should implement always our code in such a dynamic way to give the flexibility. For that, you can use runtime polymorphism concept. It's not new. Okay. Since Java beginning, they given this up. They realized this in 1995, somewhere when Java is released, almost 30 years back. Of course, we need to provide that flexibility. We need to provide that flexibility. As a hardware industry or hardware vehicles itself allowing you to flexibly you can remove anything from vehicle or anything from phone, and we can add new you know items to it. Similar way, your code also should support, your controller business DAO should support dynamically. We should able to, when business is having dependency of DAOs, when controller is having dependency of businesses, consider if you create a business class object static way in controller, they both will become tightly coupled. You can't change them. Like it will become Vasu class. But if you dynamically create objects using class dot for name, and if you use like this phone and phone implementation, sim and sim implementation, it will be easy to you to change decisions. Do we really need that feature in the coding? Do really client will change the code? Of course, they may change. They may not change. But if you give that flexibility, in case if they get into that situation, it will be easy to them to do the changes, right? So Spring following the same thing and given a lot of advantages, lot of features in terms of coding, in terms of maintenance. Okay, we'll go one by one into the Spring features. Right now we did not started any Spring example. Okay, this is simple core Java example only, but see the beauty. If you follow runtime polymorphism, we are able to achieve it. Same runtime polymorphism, Spring also following. Okay, remember this concept, very, 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 very important. Okay, so try this example yourself. Okay, I'll share this video by afternoon or evening by a new portal, and by tomorrow I'll ask you example. Okay, it is simple, I believe, right? Try it. By afternoon I'll share the new recording. Okay, maybe by just following the recording also you can do it.